Hey everybody, good morning. Today is Tuesday, January 26th, and today we're going to go over similar figures in area. This is going to be very similar to yesterday, just in that we're still working with similar figures. And you recall that yesterday we did perimeter of similar figures. So, as we start getting into this, what is the scale factor? Right, that's a definition here that we kind of talked a little bit about yesterday. If you watched that notes video and did the practice, it should be pretty understanding. But it says, what is the scale factor of the two figures? So if we're looking, and you'll see these are actual identical shapes, right? So you have 4 and 16 on the sides. So the scale factor of any two figures, you just take those sides, write it as a ratio. Alright, so in this case, the scale factor is 1/4, which means that this smaller shape is 1/4 of the bigger shape, and vice versa. If I want to go from this one to this one, it would be 4, right? So this one to this one would be 4 for the scale factor. This one going backwards would be 1/4, okay? What is the scale factor of the perimeter? We did this earlier as well. Remember that it was 16 for this, so 4, 4, and 4 gives you 16. 64 of the big one is the perimeter, which also simplifies to 1/4. So the scale factor of the sides and the perimeter are the exact same, okay? That is always going to be the case in a similar figure. But the area is a little bit different. So let's go ahead and find the area of these two shapes. We know that they're squares, so that means their sides are 4 and 4, and 16 and 16. So this one is 4 times 4, which is 16. And then this one is 16 times 16, which is 256. So what is the ratio of the small square and the big square's area? Well, it's 16 over 256, or 16 to 256. Okay, now that simplifies, of course, to 1 over 16, and that, of course, simplifies as saying 1 squared over 4 squared, right? So what you can see is that the scale factor and how it's different than the first two is that the perimeter okay, ratio is down here. It is small side over the big side, right? Which is the exact same, okay, as the similarity ratio. So once you find that, small side over big side, the similarity ratio, you automatically know the perimeter, okay? But with area, you take that small side, which in this case, was 4, and you say the small side squared. Remember, we had 4 squared over 16 squared, which is 16 over 256. So the area is the small side squared over the big side squared. Okay, so that's a difference. Is perimeter is just the small side over big side. Area is small side over big side, but you square both numbers. Okay. All right. So let's go through for each pair of these similar figures, find the ratio of the perimeters and ratio of the areas. So the perimeter here would be 4 over 5, right, side to side. The area, of course, would be 4 squared over 5 squared. Again, think of it like you're trying to find the area. 4 times 4, 5 times 5. So this would be 16 over 25. So notice the ratios of the perimeter and area are a little bit different. Same thing here. Okay, find the side that goes together, which in this case would be the 3. It's on this side, and the 5. So perimeter would be 3 over 5. Okay, the areas, right, depending upon what it would be, for the area on this one, it would be that same number. That ratio would be 9 over 25. Again, this is not necessarily the area of the triangle. We know that the area of a triangle is a completely different formula, but this is just saying the ratio of the area is going to be 9/25. So the ratio, not the actual area. Okay. Same thing with perimeter, right? The perimeter ratio, it doesn't mean that that's the actual perimeter. The actual perimeter of this square is not going to be 4/5, right? But it'll be 4/5 is that ratio. It's 4/5 of the total ratio. Okay. Same thing here. Find the side that goes together. It looks like 4 and it looks like 3. So the perimeter would be 3/4, whereas the area would be, take that small side, which is 3, square it. Take the big side, which is 4, square it. And so the ratio of this area would be 9/16. Okay. So again, we're going to continue going through here and just looking at this. And this says, same shapes as yesterday, just to keep it simple. The area of the small arrow is 24 inches squared. What is the area of the large area? Area of the large arrow. So again, 3/10, right? 3 to 10, okay? And then that is equivalent to, and don't forget it's area, so it's not perimeter, so we have to square it. And that's got to be equal to the area of the whole thing. So if the area of the small is 24, okay, then what's the area of the big? And we don't have to square this because it says that is squared, right? It says 24 inches squared already. And then we want to know the area of the big thing. Okay, so this is going to really be like 9/100 equals 24/a, or x, I'm sorry. And then 9x equals 2400. And then when you divide by 9, x is 266.7. So that would be the area of the large arrow. So again, how do you find the area? You use the ratio of the areas, which is small side squared, big side squared, and the area of one shape to find the area of the large shape. Okay, so set up your proportions, right? All right, let's continue working through some of these examples. For each of the similar figures, the area of the small figure is given. Find the area of the large figure. So, area of the small figure is here. The ratio is this. Small figure is 20. What's the big one, right? So 25/144 equals 20/x. Cross multiply, you get 25x equals 2,880. Okay, and then when you divide by 25, you get 115.2. Okay, so there's your answer there. There's your area of the big one. So you use the ratio of their sides squared in the area to find the other one. Same thing here. Okay, so ratio of their sides, 7 squared over 15 squared. And again, we're squaring them because we're looking for area. Small over big. Okay, so 49/225 equals 84/x. Okay, cross multiply, 49x equals, use your calculator here, 18,900. Then divide by 49. And x is 385.7 centimeters squared. So there's your area of the big one. So again, ratio of the sides, it's area, so we square it. If it were perimeter, we would not have those. Area of the small, area of the big. Okay, same thing down below here. So 12/27 squared. Oh, I'm sorry, I'm looking down at this example 3. It's actually working backwards. This says area and area already, so we are working backwards to find the ratio of the perimeters. So this is going to be 12/27, because that's already the area, equals, let's see, you got to find the ratio of the perimeters. Well, that's going to be 3. What do they have in common? Well, let's just simplify it. Let's just do that. Let's simplify it. So you have 12 and 27. Okay, so this is the ratio of their areas. So these both simplify to, they both have a 3 in common, so it goes to 4/9. Okay, and again, this is area, and what did we do before with the area? We squared it, so we're going to take the square root to both. gives you 2 over 3. Okay, and that's it. That's all you need. So you have the ratio of their perimeters. Okay, and then same thing here. So you have the area already. Okay, do they simplify? Not necessarily. Oop, I went wrong way. I went big over small. 1 over 4. So we're just going to take the square root of those, which gives you 1 over 2, and that's your perimeter. Okay, so to work backwards, you take their areas, simplify if possible, and then take the square roots. All right, so complete the practice.